Okay, so just some example questions from 2-3, and I'm just going to go through 2-3 number 1. Had a couple of people ask me about questions 1 through 4, so I'm going to go ahead and go through these real quick and talk you through. So this starts with h of x equal to negative x squared plus 4x. And the first part, A, is asking you for the limit as x approaches 4 for the function h of x. So when you substitute in 4 into the equation, so you're going to substitute it into those two parts, you should end up with negative 4 squared plus 4 times 4, resulting in 0. Okay, so for part B, same thing, you have the limit as x approaches negative 1 for the function h of x. Same thing here, you're going to plug in negative 1 squared plus 4 times negative 1. This will result in a limit of negative 5. Now, to prove this, what you'd want to do is, obviously, if you had a graphing calculator you could use, you would throw this into y equals, so I threw the function in, and then check the graph. So if you go, or the table, so if you go second graph, you'll see that we verify that when x is negative 1, y is negative 5. And if I scroll down further, you see where x is 4, y is 0. And so in both of these cases we've proven, I'll just bring this down so you can see it, we've proven using both substitution and the calculator to verify that, you know, these are the values that we obtain. Alright, so for number 2, in the same section, this is question number 2. So question number 2, we have the function g of x equal to 12 parentheses square root of x minus 3 all over x minus 9. And so they're asking us to check out the limit. So we start with part A. You have the limit as x approaches 4 for g of x. So as we're substituting in the values, we get 12 parentheses square root of 4 minus 3 over 4 minus 9. And same thing applies here. We can actually also use the calculator to verify this. So this is going to obviously result to 2 minus 3, which is going to give us a negative 1. So we end up with, in this case, 12 times negative 1, negative 12 over negative 5. And obviously the negatives cancel. And we know that 5 goes into 12 2.4 times. So that's our limit for this one. For part B, same thing applies. So we're going to do the same thing. So limit as x approaches 9 for g of x. And so 12 parentheses square root of 9 minus 3 all over 9 minus 9. And resulting in, I'm sorry, as x approaches 0, my apologies. So 0 here, and there should be a 0 here. Okay, so this ends up becoming negative 36 over negative 9, which is going to cancel out, the negatives will cancel top to bottom, leaving you 4. Again, using the calculator, same difference. You would go to y equals, and you're going to put in the equations. You have 12 parentheses second square root of x, push over, this be minus 3, close parentheses, and all of this divided by, I'm going to put it in parentheses even though the question doesn't show it in parentheses, just for the sake of order of operations, because the calculator is not as smart as you are. So second graph. So the first one we're looking at is as x approaches 4, so I'll scroll down to the 4, and you'll see This is giving us a negative 2.4. Again, order of operations. So let's go back to the calculator and see what happened. So this should be 12 square root of x minus 3. Okay, I think what's happening is an error here. So hang on for a second. Let's clear that out. And it's a good learning moment. So if you notice, I didn't put a parentheses there after the x, and that will help with the order of operations. So square root of x, put a parentheses to close out that function, part of the function, and minus 3, close parentheses again, divide sign, and again parentheses, x minus 9. Okay, so now when we go to second graph and we go down to the 4, you see our 2.4 is now positive. Because what was happening was the order of operations, if you don't separate this part of the equation, the square root of x, away from the 3, the computer or the calculator is assuming 12 parentheses square root x minus 3. So it's looking at it as this type of function. And this is not what we want. Okay, so that's why in the calculator you want to do that. So it separates it. Alright, going back to the calculator just for visual. The other limit that we're looking at is as x approaches 9, so it was 9. Okay, well I'm looking at it from x approaches 0. So x approaches 0, when x is 0, you get y is 4. And here it is as x approaches 9, you notice you get an error. Obviously the 9 minus 9 at the bottom would cancel to give you a undefined equation. So, alright. So the next one I want to look at is number 3 in this section. So number 3, we have f of x is equal to x cosine x. And we're looking at the limit for part A, the limit as x approaches 0 for f of x. Alright, so when we look at this equation, we know that if I put in 0 times cosine 0, right, this obviously is going to equal 0. Let's see that in the calculator, so let's go ahead and do that. So we'll clear this out. I'm going to put in x cosine x. Alright, and we're going to go to second table, so second graph. Scroll up to 0, and there you are. Alright, and then the other one is going to be for part B. We're going to look at the same thing, but this time we're going to look for pi over 3. So we're going to go second trace, value, let it do its, little dance. So there you are. And now what we're going to do is we're going to go second pi, divide sign 3, and hit enter. You get approximately 0.5235, which would round to approximately 0.524. So that verifies part B. So here we're looking at the limit as x approaches pi over 3 of f of x. So in this case we have pi over 3 cosine pi over 3, and this results in 0.524 rounded. Now I want you to also look at the graph and understand that we're looking at pi over 3 being approximately here. So you need to go back to the basics of when you look at an actual